get recording. We're actually going to go over our quiz from yesterday. If you did not turn in your quiz by midnight last night, it is a 0. You know that you have either the Zoom or the assignment to get your quiz, to get your attendance. But as far as our grades are concerned, guys, you need to get your work done daily. All right. So, again, if you didn't finish the quiz from yesterday, you got a 0. There was no reason that you shouldn't have turned something in. Those of you that did turn it in, you actually got a 100 just for turning it in. So sometimes I'll take for real grades and sometimes I won't because I'm seeing a lot of mistakes. I don't want to hurt your grades too much, if that makes sense. So we're just going to go over this quiz because today you're going to do another piecewise functions, quiz, whatever. So your assignment today is piecewise again. So I just want to go over it one more time before we start, and this is the best way to go over it. So if you have your quiz handy, go ahead and get it out, and we're going to go over it. And you can check your quiz on your own and see how you did. If you didn't do it, now you have some more notes. And then if you did it wrong, you can see where you got it wrong and ask questions, okay? So make sure that you guys are paying attention, all right? And then I'm going to ask again to make sure that you're in the Zoom a couple minutes early, please. Please don't be late. So if you're past 8:40, it just takes time, that's all. So you're not hurting anything, it just takes time. All right, so on number 1, it's going to be a lot of me talking. I might ask a couple questions. If I do, please answer. Y'all be on time. All right, so our boundary is at -2. So I'm going to graph at -2, this boundary line. The first one tells you it's less than, so it's to the left, and it's open because it's not equal to. So we're going to graph x plus 5 on this side. And again, you don't have to write all that on there. That's just reference for you guys, okay? The bottom one is pointing to the right, and it is equal to, so it is closed. So we're going to do -2x minus 1 on this side. All right. Like I said, I like to use my calculator just to get the points because I'm being a little bit lazy, and you guys can do that. We want to look on the boundary at -2. So our coordinate is -2, 3, and it is open. -2, 3, and it is open. I want everything to the left. So -3, 2, and you guys can see the pattern after you go for a while. I like to go all the way across the graph because I do want you to do domain and range. If you didn't do domain and range on your quiz, it's okay. Don't stress out, but we do want to go over that as well because that will be on your test, okay? So graph that function on the left. Any questions about that function right there? All right, so we're going to do the next one. -2x minus 1. We're looking for -2. Now this one is -2, 3 as well. So it's the same point that we opened up. So I'm surprised you don't have any questions about this. Some of you, nobody asked me questions about this, and we didn't go over one like this. So when you have this and it graphs it, this one is a solid point. You just fill that point in. So it becomes a closed circle instead of open, okay? So it's still the same point, it's just closed now. And then we go every other one on the right. So -1, 1. And if you guys look, your pattern is going down 2 and over 1. And again, I like to go all the way across my graph just for the domain and range purposes. Okay. I'm going to go ahead and do domain and range, and then we'll do the evaluation. So if you did not do domain and range on your quiz, don't freak out. It's okay. I just wanted you to practice, so that's not a problem. What it asked you to do was evaluate and graph, and that's it. Okay, so if you didn't do domain and range, that's fine. There is also a domain and range quiz that you guys should have taken. It was a really, really, really simple quiz. So make sure if you haven't taken that specific quiz, you go back and take it, okay? So our domain, remember our values from left to right. On the left, as we move across, what do we see? Come on, guys. Don't make me wait today because you know it. I see your grades. I know what you can do. Please answer and don't waste our time. You have an assignment today. You want as much time as possible. What do we see on this side? Where does our domain go to? Negative infinity. Thank you. Again, parentheses because negative infinity doesn't really count. As you go across, We see all solid points, no open. Remember, we closed that one up so it's solid. We keep going. What do we see on the right? How far does it go?
Positive infinity.
Perfect. Thank you. Then we're going to do our range from the bottom. How low does it go? We see arrows at the bottom. So it goes to negative infinity. We see graph touching this little notepad all the way up until we get to the point of 3. So 3 is our highest point, and make sure we include it because it is solid because we filled it in. Okay. So again, if you didn't do domain and range, don't freak out. Do it today. Just a forewarning, we review tomorrow and test on Friday. Okay, you can see it in the modules. It's not a secret. Okay, so review tomorrow. We need to make sure we know how to do domain and range. Domain and range part of the graph, part of the test is usually the worst part. Okay, so I want to make sure that you know how to do it. All right, so f of 3, to evaluate, we look at our two functions. Is 3 less than negative 2, or is it greater than or equal to negative 2? Another way you can do it is if you've graphed it, you can go to 3 on the x and find out where your graph point is. It's that simple. If you want to do that after you've graphed it, that is perfectly fine. Otherwise, 3 is bigger than negative 2. So I'm going to use the second function, and I'm going to plug in that 3. So negative 2 times 3 minus 1. Which is negative 6 minus 1, or negative 7. So if we go to 3, 1, 2, 3, and we look at this point, it is at negative 7. So 2 ways you can do it. If you've already graphed it, use your graph. If you haven't, you can just plug it in. It's fine. All right. If we look for negative 4 is less than negative 2. So we're going to use x plus 5. And we're going to plug in negative 4. Negative 4 plus 5 is 1. Again, if we go to negative 4, your coordinate at negative 4 is positive 1. I don't care which way you do it. All right. Negative 2, if we guys look at this, both of these have negative 2, but only the bottom one says equal to. So we use the bottom one because it's equal. So we use the bottom, negative 2x minus 1, and we plug in negative 2. Negative 2 times negative 2 is positive 4 minus 1 is 3. If you guys look on negative 2, that's positive 3. Any questions? Again, I don't care if you use the graph or if you plug it in. So I showed you both. All right, your next one. We have a boundary at 1. Be careful, this one is actually the right side because it's bigger, so greater than is to the right, it's pointing to the right, and it's closed. So on this side, we're doing 2x plus 1. This one is left and open. So we're doing x over 2 minus 3. Is this the one with decimals? Yeah. All right, so we're going to graph. Again, I just used my calculator. We're going to start with 2x plus 1. On the boundary line of 1, our coordinate is 1, 3, and it said it's closed. And we're graphing to the right, so that means bigger, 2, 5. And then you should see your pattern up 2 over 1. Okay. For the second one, you have x over 2 minus 3. You can do it like this. You can do alpha y equals. I'm not a fan of alpha y equals on this one, only because when it gives you your table, it'll give you fractions. And most of you like decimals when you're trying to graph. Okay. So we're going to go to our table. At 1, it's going to be an open circle because that's what it tells us. So 1, negative 2.5. And you guys don't have to make it perfect. We just know that it's open in between. Okay, open in between. We're going to go to the left. I'm only going to graph the whole numbers now. Okay, so we started at 1. We're going to go to the left. So 0, negative 3. -2, -4, and hopefully you can see that it's over 2 and down 1. And I go all the way across the graph for my domain and range. Any questions on this one? Is everybody okay? All right. Going to review domain and range. For our domain, we're going to go to the left. What do we see on the left? Negative infinity. As we move, we see graph touching this notepad. We get here and we have this gap, but we have an open circle and a closed circle, which means we just ignore it and keep moving. So how far do we go to the right? So our domain is actually negative to positive infinity. The range is where it gets tricky. This is why I wanted you to, I thought you would ask some questions. I had one person ask questions on this assignment. One. Okay. If you have questions, ask. It's okay. All right. So we haven't done one like this where the range is kind of weird with this gap in there. Okay. So again, if you have questions, just ask. We're going to start at the bottom. If you got it right, good for you. So when we get finished, if you got it right, you're doing amazing. Okay. At the bottom, we go to negative infinity. As we move up, we see a hole. Where was that hole at? What was that coordinate? 1. Y'all remember? Where did we put it? 1.
2.5.
Yep.
-2.
-2.5. So we have to stop there. And since it's open, we have to use a parenthesis. Since we don't touch anything else, we don't pick back up at that 2.5, that -2.5. There's a gap. So there's going to be a gap in your range, okay? So we pick back up at 3. You guys see that? Nothing here. Nothing's touching my notepad. And then all of a sudden at 3, we do. So we still do the U. And then at 3, it's a closed point. So we bracket it in. This one's really weird, okay? But then we go all the way up to what? Infinity. Infinity. So again, why does this one look weird? Because it has a gap. Now, if they would have just continued, then we would have just continued with the -2.5 because we have that gap. We have to show that gap in our range, okay? So if you got that right, great job. If you didn't, don't stress out. We haven't done an example like that at all. So that's why I wanted to go over this quiz, all right? So then look at your evaluation. You can either plug into the functions up here or you can find -2. So here's -1, -2, and we look down and that coordinate is -2, -4. So we should have -4 when we finish. Otherwise, we know that it's less than 1. We plug it in, we get -2 over 2 minus 3, which is -1 minus 3 or -4. Okay, I don't care which way you do it. If we look at 6, 6 is greater than or equal to 1, so we're going to use 2x plus 1, and we're going to plug in 6. 2 times 6 is 12, plus 1 is 13. 1 is equal to 1, so we're going to use the first function, 2x plus 1. Plug in the 1, so 2 times 1 is 2, plus 1 is 3. Any questions? Evaluating should be pretty easy. So the way that your test is set up, your review is set up the same way, but the way your test is set up, you're going to do transformations and evaluations at the same time. So that is one of your goals. So your transformations are up, down, left, right, reflect X, reflect Y. Okay. And then you're going to do those. So 5 of each. Domain and range is its own entity. You have one whole goal that's there. I'm going to grab another sheet because this pen bleeds through, so I don't want y'all to see that. So we're going to keep going, okay? So on the next one, your boundary is at 2. So we're going to graph our boundary at 2. first one is greater than, so it's to the right and closed. So on this side, we're doing 4x, sorry, minus 2, 4x minus 2. And then this one is left and open on the boundary. So x over 3 plus 4. And again, when you get something like that, if you want to skip coordinates, so you're just doing the whole number coordinates, that's perfectly fine. You don't have to stress out about it. All right, so we're going to go into y equals, and I'm going to put in my 4x minus 2. And I'm looking for my boundary point 2. So 2, 6 is closed. 2, 1, 2, 3, 4, 5, 6 is closed. And I want stuff to the right. So 3, 10. And that's all you're getting on this graph. Okay, that's all you get. The next one is negative x over 3 plus 4. We're going to check our boundary point at 2. It's really nasty, right? Yeah, it's okay. It's okay. It's an open point at 3.3. So this is what I do. I just make a big point in the middle. It doesn't matter where it's at, okay? Because I over-exaggerate the circle, I just make it inside. Don't stress at all. All right, and then we got to go less than, so 0, 4. And then I see negative 3, 5. And you can see your pattern is over 3 and up 1. So it looks like this. And I'm just going to put this out there that was 3.33 or 3 1/3. Y'all don't care. 10 over 3, whatever you have is perfectly fine. Okay. All right, so our domain. On the left, we have an arrow, so negative infinity. As we go to the right, there's an open circle, but there's a closed one that touches it as well, so we ignore it. And then we keep going forever. So your domain on this one is negative to positive. Okay, so this one looks like it has a gap too, but watch this. When I go from the bottom, the lowest point is that 3.33 and it's open. So I'm going to leave it like that. As I move up, I'm touching graph, I'm touching graph, I'm touching graph. So there is no gap here. Does everybody see that? Because at some point it's still touching that notepad. And I'm going to pull all the way up and it goes all the way to infinity. So that's it. That's all you got to do. To evaluate, pick the function. It doesn't matter. So negative 4 is less than 2. So we plug in that coordinate, a negative 4 over 3 plus 4 gives us, you can do it a bunch of different ways, positive 4/3 plus 4 is 5.3. Repeating, you can just put 5.3. Okay, so hopefully you guys got that right. If you did the fraction, 16 over 3. I don't care. Okay. If you did 5 1/3, also the correct answer. I don't care what form you put it in. Okay. 8 is greater than 2, so you're going to use the first function, and we're going to plug in 8. 8 times 4 is 32, minus 2 is 30. All right. And then 2 is equal to 2, so we're using the first one. And we're plugging in the 2. 4 times 2 is 8. Sorry, talking and writing. Minus 2 is 6. Any questions on number 3? Are we doing okay on the graphing? Graphing part is good. And evaluating is good, right? So just keep practicing that domain and range. All right. Zoomers, again, if you have any questions, please stop me. This time we have 2. We have one at 0 and one at 5. The first one is less than, so that one's going to be on the left. And it's going to be closed, so negative x plus 4 goes on the, sorry, I don't know my right from my left apparently. Is going to go on the left. The next one goes in the middle because it's between 0 and 5, so 2x over 3 minus 1 is going to go in between there. The left boundary is open, the right is closed. And then the last one is going to go on the right, and it is open. So just 2 over here. Okay, I don't have to do this, but I'm going to do it for you. If we graph just the 2, on the boundary, it is open. So 2, 2 is open. And then it's just a horizontal line this way. So it should look like this. The next one is 2x minus 3. I'm sorry, 2x over 3 minus 1. On the 0 boundary, we have negative 1. Look at this. On the 0 boundary, it's open at negative 1. 0, negative 1 is open. And again, I over-exaggerate it. On the 5 boundary, it's at 2.3, and it is closed. So I'm just going to put a closed dot. Those do not overlap. Understand that. They don't color each other in. Okay, they're not at the same spot. You can get numbers in between there if you like. There's a 3, 1. So you can connect it if you'd like. Oh, I connected the wrong way. Sorry, y'all. Sorry, y'all. Sorry. This little line doesn't exist. There you go. Just this. All right. And then the last one, negative x plus 4. On the boundary of 0, we have 0, 4, and it says it's open. As we go less, you can see your pattern is up 1 over 1, and then I go all the way across. Okay, so this domain and range is going to be crazy as well. Okay. Our domain, on the left, we have an arrow over there, so we're definitely going negative infinity. As we move over, you guys see that on 0, there's 2 open circles, right? So we have to stop there, and it doesn't fill in, so it's going to be an open circle. We pick right back up because those graphs are connected right there. So we still see graph connected to that. And we go all the way to 5, but 5, we have an open and a closed, right? So that closes that all the way to infinity. So the only open point is going to be at 0. All right, so our range, the lowest it goes is negative 1, not included because it's open. It goes up, 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 up. There's an open circle, but there's a closed one touching my notepad, so we're good. What was that coordinate right there? Did I graph this one wrong, didn't I? Did I graph it wrong? I feel like that was a 5.3. That might be the other one though. Y'all got to tell me if I screw up. I'll be surprised if I make it through this whole thing without screwing up because I never do that. 5. Oh, I did. I was good. This is 2.3. So we go all the way up to 2.3. And it's included, but we have a gap between 2.3 and 4. 4 is not included. And then we go up to infinity. So let's go over that one more time. So the reason we have -1 open, it's an open circle at -1. That's our first coordinate. We go all the way up and we see another open circle, but to the left over here, I have some graph that I'm touching, so that's ignored. But then we stop at 2.3. There's no other graph touching. We have to jump to the next point. So we have a closed point at 2.3, so we close it up. But then we still have more graph left. We pick back up at 4, and it is open because it's an open circle, and then all the way up to infinity. Okay. -2 is less than 0. So we're going to use -x plus 4. We're going to plug in -2. And we get 2 plus 4 is 6. 0 is equal to 0. So we're using the first function again, -x plus 4. We're going to plug in 0. 0 doesn't matter, so we get 4. And then 5 is equal to 5 in the middle one. So we're using 2x over 3 minus 1. This one's going to be crappy decimals. So this one is 10 over 3 minus 1, which is going to be 7 over 3. If you want the decimal, again, use your calculator the whole time. I don't care. Gives you 2.3. Again, if you change it to a fraction, 7/3. I do not care how you give that answer to me. Okay. Any questions on number 4? All right, 2 more, and then I'll get you your assignment. Yep. All right, and these 2 are easy because it's just 2 points or 2 graphs. It's not 3. So this one is at 0. This one says left and closed. Less than is left. This one says right and open. I'm going to start with the right side. -4x divided 3 minus 4. On the boundary point of 0, my coordinate is 0, -4, and it says it's open. Okay, our inequality tells us it's open. We're going to graph to the right. So 3, -8 is my next whole point, and that is perfectly fine. There's nothing else that I can graph on here. You do not have to graph all the decimal shell. I would not. Go to your next one, -x plus 1. My boundary line is 0, so my coordinate is 0, 1, and it says it's closed. And then we're going to the left, so -1, 2, and you can see it's going up 1 over 1. And again, I like to graph all the way across just for my domain and range. So check it out, make sure it's right. On the left, I have an arrow, so that means I'm going to -infinity. As I move, I have an open circle, but I have a closed point touching it, so we ignore it, just cancel it out. And then I have an arrow on the left, so your domain is negative to positive. Also remember that your domain and range always goes less than to greatest, okay, least to greatest, always. On the range, the bottom number, it's an arrow, it's going to be -infinity. It goes all the way up to -4, but -4 is open, so we open it. We don't continue, we have a gap. So we have that union, we have a gap, we pick back up at 1, and it's a closed point. So we bracket that, and then it goes all the way up to infinity. So there's your domain and range. All right. -4 is less than 0, so we're going to use the first function. We get -4, which is +4 plus 1 is 5. 0 is equal to 0, so we use the first function. -0 plus 1 is just 0 plus 1 or 1. Where are you at? Oh, your sister get here on time. You don't. Was she? Oh, I thought he said she was in class. We were talking about y'all this morning. All right. We're just going over the quiz that we did yesterday. So we're on number 5 of that quiz. And then 3 is greater than 0. So we plug in 3 right there. Negative 4 times 3 is negative 12. Over 3 is negative 4. Minus 4 is negative 8. Okay. So you should have 5, 1, and negative 8. Any questions on number 5? All right, last one, number 6. Boundary lines at 3. And I'll give you mine so you can check yours. I told them if they did it, then it was 100 in the grade book. If they did not, it was a 0. But then I went over it because your assignment today is piecewise functions again. Okay. All right. So this one says left and closed. So we're graphing that over here. This one is right and open. So we're graphing over here. I'm going to start with the 2x minus 5. The boundary point is 3. So 3, 1. And it's open. 3, 1. And it's open. And then we're going to the right. So 4, 3. So if you look, we're going up 2 over 1. And again, go all the way across the graph for your domain and range. On the left, we just have negative 3. The only thing that people tend to mess up on this is where it, like you put positive 3 instead of negative 3. So watch your signs on this one. So I'm going to do it in my calculator just so you guys can see it. Our boundary point is positive 3. It's at negative 3 and it is closed. 1, 2, 3. And then everything is graphed. It's a horizontal line graphed on the left side. For domain, we start on the left. We see that it's an arrow, so negative infinity. As we move, we see an open circle, but there's a closed one touching it, so we just keep going and ignore it all the way to positive. So negative to positive infinity. Your range is where it's a little bit crazy. Okay, watch those vertical and horizontal lines. They make things crazy. The first coordinate we have is negative 3 on the y-axis. It is all closed because I have a closed dot touching my notepad, okay? So it's closed. But then I have a gap. So we're just using the negative 3. And then we pick back up at positive 1, but it's an open circle. And then we are all the way up to infinity. Okay, that one's kind of weird. Watch those vertical and horizontal lines, okay? Negative 4 is less than 3. So we write down our function, which is negative 3. On this one, we don't have anything to plug in, so we're done. That's it. You can't plug in negative 4 to the function that doesn't have an x. Got it? Again, if you use your graph, I told you guys if you'll use your graph, go to negative 4, 1, 2, 3, 4. What is your coordinate that's graphed? Negative 4, negative 3. Okay. At 0, same thing. If I go to 0 on the graph, what is my coordinate going to be? Negative 3. 0 is less than 3, so we're using the function negative 3. You may use your graph, okay? On your test, it'll be the same graphs for your piecewise as it is for your evaluations, okay? So once you graph them, you can use them. Now, you might have to flip back and forth between the quizzes because we have them split up, but they're there. All right, positive 3. If we look, positive 3 is equal to 3. So we're using negative 3. Look at this one more time. If you're trying to evaluate, because you might have this on your final exam and they just give you a graph and they say, what is f of 3? We go to 3 and we see 2 points. This one doesn't count because it's open, so it doesn't really exist. It's not really there. So we would use the negative 3. Okay, everybody got it? All right, so that's 1 through 6. I'm going to stop recording and stop sharing, but you guys don't go anywhere.